Okay, week 3 in a nutshell. So we covered strings, pointers, functions, and passing by value and reference to those functions during week 3. So I'm going to start with pointers because strings are basically pointers as well. So let's go from less to more complicated subjects, I suppose. So if you want to use not strings, but pointers in general, and malloc and so on. I think I didn't use malloc actually. Okay. So I'll add some malloc in a second, but you need to include that standard library .h. This one is the most common, the most basic library that probably there's no point starting without adding this. This one is for pointers and so on. Basically, libraries work the way that if you want to use the functionality of it, you have to include it. If you don't want to, if you don't need that functionality, let's say there is a string library that you can include, and then you can copy and concatenate and so on the strings. So that's when you include it, when you need to use them. Otherwise, we are not concatenating strings here, so I'm not including this. So here you declare your functions that I'm gonna explain in a second. First, they're not implemented. You just say, hey C, you'll see those functions below. Don't freak out. There is an explanation below, okay? If you don't put that in, it's gonna crash. It's gonna say there's some implicit reference to that name, but I don't know what that is. Although it's all the way underneath the main function. And the thing is, you can implement your functions above, but for some reason there's a you're supposed to implement main first and then the functions after. So this is how you do it. First, you declare it, you put the semicolon here instead of going and trying to write something in here. You just leave it with a semicolon here. Okay, our main. So let's start with pointers. So here is our plain old integer. It's not a pointer, it's just an integer variable that holds 10. Then we can create a pointer here and assign straight away. We can assign its address, the plain old integers address to that pointer, to that address. Basically, it's an address variable. Just remember that pointer is nothing else than an address variable. It holds some address inside of it, and the only confusing thing about it, and I think this is the most head-wrecking thing, is the syntax. It's the concept is super easy, and if they implemented it in a more user-friendly way or whatever, we would have so much less headache with that. But the problem is we're using that star in here in a different way. Like I put this comment here to just say, listen, if you want, you can use one line to declare and initialize your pointer to an integer. So remember, a pointer is to some type. It's not just a pointer with some address and we don't know what's at the end of it. You have the C needs to know what is it pointing at. So you have to write integer. I'm pointing at, and this is the pointer, not kind of symbol. So I'm pointing at an integer, okay? And then you assign an address to it. Yeah, you can with pointers you can assign an address to the pointer, or you can assign whatever, in this case integer, to the dereferenced pointer. So when you dereference the pointer, you go to that address, you go to that, in this case 10, and you change it there. So and in here the confusing thing is that you're using a star and then you use an address on that side, when in this case, if I did exactly the same but using this code, um, oh, sorry. So this isn't a code. So let's just grey that out. So I could use those two lines. So first I declare a pointer, and then you see there's no star. And why the hell there's a star in here and there's no star in here, although on the right side it's exactly the same. Yeah, that's the way C works. When you initialize it, when you see an int, the data type on the left side next to the pointer, then we declare it, and when we declare it, is all this is an address. Okay, this is an address. And then when you do that, pointer to integer, yeah, what do you assign there? You see it looks exactly the same. So you would think, yeah, so I'm gonna just assign an address. No, this is without an int in here, without the data type in here, this is dereferenced pointer. So we are looking at, in this case, this guy. Yeah, so we want to assign some integer in there, 15. And that's gonna basically, if we implemented this code, we would change that plain old integer to 15. Yeah, because we say, okay, I want to create a pointer. I want that pointer, that address. There's no sign here because pointer to integer itself is an address. And that's the confusing thing. In here, you need a star. In here, you don't. But this is kind of like saying, I want to create a pointer. Remember it like this. This is a symbol that you have to put in before you create a pointer. Just like you put int, in this case, you need to put int star. And you actually can do that. You can do it like this to keep it maybe less confusing to yourself. Like this is a pointer to an integer, and this is the name of that variable. And then if I want to assign an address to it, I don't use anything, no stars in there, okay? And then I can just use my address notation uh, for the plain old integer. And then when you want to dereference it, you use that star again. So in here it has different meaning, and in here it has different meaning. And that means go to that address, go to good old plain old integer, and do some magic in there, okay? But then right now I don't want to have that in here. I'll just comment that out, okay? And in here, this is the easy way. Okay, so that was the long story. And again, if you watch my longer video about pointers, maybe that's going to give you a bit more clarification. Okay, so let's have a look inside of what we are, what that means. What is the plain old integer, and what is our pointer to an integer? So we're going to look at the address of that plain old integer, which is the variable itself, integer variable itself, and we want to see the content of it. And in case of pointer to integer, we want to see it still has an address. That pointer variable has its own address, which contains an address inside of it. Yeah, it's simple enough. Yeah, every building, let's say we have a table, and every square on that table, it has some like A1, A2, A3 address, and inside you can store some information, and that information in this case is an address. And then when you dereference this pointer, when you go to that address, there is an integer there, a digit, as you can see here. So we use P for address and D for an integer, or I for integer. Okay, and you'll see it in a second. So then in my code here, okay, so we go to strings. So strings are basically pointers to a character, but that character leads to like another character and another character and another character. That's how you create this string. But the difference between an array of characters and a string is that at the end of at the end of a string, there is a \0, which tells the computer, okay, that's the end of the string. Don't go any further because you're going to read some crazy stuff that is, behind that char star, which is a string. Yeah. So I call it why so complicated strings. That's the name of my variable, and I assign. So as you can see here, I say, oh yeah, that's another confusing stuff. So in here, I'm looking at um, this bit here. So I said if I write I have a pointer, yeah, it's an integer pointer, and I'm just saying no signs, just integer pointer, the address, and I want to assign some address to it. Grand, makes sense. And in here, and it's a bit, it's because it's implemented. Somebody, forgot about thousands and thousands of functionalities that we want to have in C. In here, they said, okay, we're going to implement string, so it's really confusing. So that's how they implemented it. You can just assign strings like this. This is a string variable, yeah? Char star is a string variable, and you just assign a string to it. That's it. Done. Okay, so in here we're gonna have quotation marks, why so complicated quotation marks, and that's the string, and that's how. And the first element of that array will be my quotation mark, and then W, and then H, Y, so on. And then the last one behind that quotation mark, there's going to be a \0 allocated there. So when we want to read it, it's going to just read one by one until it hits \0, and then it stops. Okay, and here, okay, so now we want to print and see what's going on inside. So we're going to see it in a second. And then we okay, so we have our double pointers after. So we're gonna run it in a second and see how it behaves, and then we're gonna look at the double pointers. So basically, double pointer is a pointer to a pointer, nothing really complicated. Imagine there is a couple of guys, and they can do whatever. They can be they can hold an integer, they can point at something, they can have a string inside. They can do one thing at the time, but they can do all of them. This is our memory, basically. So let's say we have 10 guys standing in the middle of the room, and I say to one of them, hey, here's 10. This is an integer, and please hold that integer. And he's holding that 10, and he's the integer variable. And then I say to another guy, hey, could you point at that guy? So you're going to be a pointer to an integer. Grant, he's pointing at that guy with that 10 sign in his hands. And then another guy, I'm asking that guy, hey, could you point at the guy who's pointing at the integer guy? And he's pointing at that pointer. So this is the double pointer basically. It goes from one variable to another, and it finds a pointer inside, and then it goes to another, and then we have an integer inside. So it could be a pointer to a pointer to a pointer to a pointer. You know, if you have billions of cells in your memory, you can just point billion times to each other, as long as at the very end there is some data type, there is some int, char, or maybe struct that you created. It has to have something at the very end. That's how you say this is going to point at the end. We're going to get some integer, but in the middle we have a couple of pointers, and you can just add those pointers in here as many times as you want, as long as they actually point to a pointer to a pointer, blah blah blah. In this case, we just point to a pointer. Okay, and we're going to print that out, and then we're going to go to functions, and so we will look at passing by value, um, passing by reference, and what does it mean that the function returns something, and how can we use that return value. Okay, so I'm going to stop it here so I don't make it too long, and then next video will be with the compiled program running up and running. Cheers for watching.